All right, welcome to this explainer. Right now, we are seeing a massive fundamental shift happening in the world of drug manufacturing. It all comes down to the actual chemicals doing the heavy lifting inside our medicines, what we call active pharmaceutical ingredients, or APIs for short. It's this absolutely fascinating space where cutting edge chemistry is colliding head on with high stakes finance.
So you might be wondering, why exactly are modern medicines getting so unbelievably complex? And frankly, so highly profitable to make? I mean, the active ingredients in our pills don't just magically appear out of thin air, right? They're manufactured in massive chemical reactors. And the whole industry is actively moving away from simple, easily copied formulas and shifting toward incredibly complex scientific marvels. To understand why manufacturers are chasing this complexity, we really have to look at the chemistry itself.
In the API manufacturing world, there are essentially two completely different weight classes of molecules. On one side, you've got your small molecules. These are simple, chemically synthesized compounds, basically the traditional baseline of the entire pharmaceutical industry. But then on the other side, you have peptides or biologics. Now, these are much larger, highly complex molecules that have to be built through incredibly demanding and specialized processes. To really picture the difference, just think of a toy box. A small molecule is kind of like a single Lego brick. It's simple, standardized, and extremely easy to snap together. Pretty much any capable factory out there can make it. But a peptide, that's more like a delicate change of 100 Lego bricks, all linked together in a highly specific order. If literally even one single brick is out of place or just snapped on slightly crooked, the entire chain fails and the medicine just doesn't work. The sheer precision required here is absolutely staggering. And how this immense scientific difficulty translates into a massive business advantage is what we call the complexity moat. You see, if a medicine is as easy to make as snapping a single Lego brick, well, anyone can do it. And when anyone can do it, it just becomes a generic commodity, and profit margins immediately get crushed by the competition. But when extreme manufacturing difficulty is required, when you have to flawlessly link 100 bricks together in these sterile, highly specialized reactors, that difficulty literally becomes your strongest protective barrier. Because so few companies in the entire world can actually pull it off, the ones that can hold massive pricing power. So this scientific difficulty builds directly into real-world strategy. There is a massive shared strategic bet happening right now across the biggest anchor companies in the API industry. They are not trying to just pump out more of those cheap, simple, small molecules. No way. Instead, they are completely pivoting their massive manufacturing infrastructures toward harder chemistry, aggressively building up their peptide capacity. So, what does this industry-wide pivot actually look like on the ground? Well, because of that complexity moat we just talked about, peptide APIs command materially higher profit margins. And right now, this is being fueled by a totally unprecedented global demand wave for GLP-1 therapeutics. You've probably heard of them. They're those highly effective weight loss and diabetes drugs making headlines absolutely everywhere. Because of this surging demand, major API manufacturers like DV's, Loris, and Newland are explicitly targeting peptide chemistry as their top vector for future growth. Newland is actually commissioning a massive, dedicated peptide facility slated for July 2026. Make no mistake, this is the industry's absolute biggest bet for margin expansion. The era of easy, high-volume, simple chemistry is definitely maturing. Looking ahead, the future clearly belongs to those who can master the absolute hardest manufacturing processes on Earth. So that leaves us with one big question. Who will actually win the high-stakes race to manufacture the next generation of complex medicines? Because the companies that successfully build out this peptide capacity won't just be making drugs. They are going to be building unassailable fortresses in the global supply chain. Thanks for hanging out with me for this explainer, and definitely keep an eye on how this complex chemistry continues to completely reshape the business world.